So again, I need to identify the certain things that are given to me in this information and then try and solve it from there. So straight away I can see that my A1, or my first term, is equal to negative 23. I can see that my common difference is 12, it's increasing by 12. And I can see that my nth term, so my nth term is 115, and that's the one that I'm trying to determine what position it lies in this sequence. So what I'm going to need now is my general form. So an is equal to a1 plus n minus 1 times d. So my an is 115, or that's what I'm trying to test, is equal to negative 23 plus n, I don't know yet, so I'll leave that as a variable, n, times my 12, which is my common difference. Okay, and from there I'm going to have to expand out my brackets, so remember to do that. So I get 115 is equal to negative 23 plus 12n minus 12. And I get then 12n, when I collect all my like terms, I get 12n is equal to 150, and I get n is equal to 12.5. Now, because it's not a whole number, that tells me that this number 115 lies between the 12th and the third number, so therefore it does not belong to the sequence. So no, does not belong. As it lies between 12th and 13th term. Okay, so just make sure you write that statement as well. Okay, the next example that we have to do here is write the first 4 terms of the arithmetic sequence when we know that the third term is 19 and the 20th term is 121. So what can we identify? Again, I'm going to identify that my T3, or my A3, doesn't matter which one you use, my T3 is equal to 19, and my T20 is equal to 121. Okay, now from my general formula, I know that my 19 is going to be equal to the first term plus 3 minus 1, which is 2, times the difference, so 2d. And I know for my 20th term it's going to be the first term, a, plus 20 minus 1, which is 19d. Okay, so that's just from the general form. The Tn is equal to a plus n minus 1 d. So I just plugged this knowledge in here. Okay, so a is your first term, or it could be T1 or A1. I'm going to keep it as one variable, so it's a. And now straight away I can see that my two variables are a, and d. So how would I solve when I've got two missing variables? I'm going to use simultaneous equations. So I'm going to call this 1 and this one 2. And I'm going to do 2 take 1 and work out my unknowns. So if I do 121 take 19, I end up with 102. I'll just go back to my blue pen. So 102 is equal to a minus a, they're going to cancel. And my 19d take away my 2d is going to give me 17d. So 102 is equal to 17d. So d is then equal to 6. And I can then say that 19, so therefore 19 is equal to a plus 2 times 6. So 2 times 6 is 12, so a is going to be equal to 7. So now I've solved for my two unknowns, and I'm asked to find the first 4 terms. The first 4 terms is, well, my a is my first term, so that's going to be 7. Common difference is 6, so my next term is going to be 13. Then I'm going to have 19, and the last one, the 4th term, which is what I need, is going to be plus another 6, which is 25. So these guys here are the first 4 terms in that sequence. Okay? Perfect. Okay, so now we're going to look at the arithmetic series. So as I said, the series is when you're involving the addition signs. So you take the sequence and you add them all together, so you're trying to find the sum of that sequence. Okay, so the series, it's referred to the series. So Gauss's method, he used a method. So Gauss was the child prodigy, basically. He lived from 1777 to 1855. And one day at school, his teacher, to try and keep the kids busy, she asked them to add up all the numbers from 1 to 100. And within no time, Gauss put down his slate on the table and said that he had it. And what he had, the teacher wasn't amused, but then she realised that he actually did have the right answer once they all worked it out. And he said, when she asked him, he said that he observed that 100 plus 1 was going to be 101. Okay, so if you list out all the numbers from from 1 to 100, he noticed that the 1 plus the 100 gave him 101. He noticed that the 2 plus the 99 gave him 101. The 3 plus the 98 gave him 101, and so on and so forth. And he knew that he had, if there was 100 numbers, then he had 50 pairs of numbers, which were all given him 100. And those numbers then, 50 times 101, which gave him 5,050. So that's basically the calculation, the only calculation that he had to do. Okay, so this is what we're trying to do here, with that same thought process, I suppose. So you add the two of them together. So 1 and 100 is going to give you 101. 2 and 99 is going to give you 101. 3 and 98 is 101, so on and so forth. So now what you're actually doing is you're adding two sequences together, and both sequences are the same. And when you do that, you do 101 times 100, which is 10,100, and then you have to divide it by 2 because that was two sequences. You only wanted to add up one of them, so you get 5,050. Okay, so from studying these numbers, we can see that our actual rule is the sum of all the numbers is equal to the number of terms divided by 2 times the first term plus the last term. Okay, and we know from the general formula that the last term can be rewritten as the first term plus n minus 1d. Okay, so that's where this comes from, and then you've got a t1 and a t1, so that's 2 t1s plus n minus 1. So you can use this formula here, or you can use this formula here. Okay, so that's for the sum of the arithmetic sequence, and it's called a series. So in this first example, we're asked to evaluate the arithmetic series 9 plus 14 plus 19 plus ... all the way to 224. So again, what I can identify is my first term. So my first term I can identify as A1 is equal to 9. I could call that T1 or A, so just remember the different ways of notation. And my difference is equal to 5. It's a positive 5 for increasing by 5. And the last term, or AN, the nth term, is equal to 224. Now I don't know how many terms there are, so that's why I'm calling it the nth term. And yeah, and basically we're just going to have to, we're trying to evaluate the sum. So again, I'm going to be using the form Sn is equal to n over 2 bracket A1 plus AN. Okay, so I'm using the first formula in this instance. Now if I look at my formula here, Sn, I don't know, I'm trying to find that. My n, I also don't know my n. Okay, I do know my A1 and I do know my AN. Okay, so the only missing term from this one here is going to be this n. So I have to work out my n first. Okay, so now I'm going over into the solve section, and to work out my n, I'm going to say that an is equal to, I'm going to use the information that I've given, so I know what my an over here is, so I'm going to use that. Okay, so my an is equal to the first term, a1 plus n minus 1 times the difference. So I should be able to solve this now in terms of n. Okay, so an is 224 is equal to 9 plus n is the one I'm trying to find, don't know that yet, times my difference, which is 5. Okay, and when I work all that out, I get 5n is equal to 220. Okay, so the way you might make a mistake is just forgetting to multiply out your brackets here, so just make sure you do that. Okay, and then you get n is equal to 44. So my number of terms in this series above is 44. Okay, and from there now I can use this formula to find out the sum of those 44 terms. So the sum of the 44 terms is equal to 44 divided by 2 on 9 plus 224, which is equal to 5,126. And that's my final answer. So the sum of those 44 numbers is 5,126. Okay, so again, I knew that I had to find the sum of those numbers, so I was going to use that formula, but I still had a missing variable, the n. Okay, so I had to work out that n first by doing this over here, and that was the part that took me a little bit of time. Once I had that, I could just find the answer really, really quickly. Okay, the next example, if 10 plus 13 plus 16 plus ... all the way to tn, which is the nth term, is equal to 198, how many terms are there in the series? So we start off again by identifying key information. So I'm going to say T1 or A1 or A is equal to 10. I'm going to say that my common difference is 3. And I'm going to say that the sum of the terms is 198. So I can read all of that here from this information here. So 10 is my first term. 10 to get to 13, I've added on 3, so that's my difference. And my Tn I don't know, but I do know my S of n, which is the sum of all those terms, is 198. That's that information there. Okay, and how many terms there are, that's what I'm trying to find. So I'm trying to work out what my n is equal to. Okay, so again, think about your formulas that you have. So I'm going to need the formula Sn is equal to n over 2 on 2 times T1. So this is the third equation that formula that we used back there. N minus 1 all on D. Okay, so that's just the reshuffling of T1 plus Tn. Okay. And then plug in what I know. So from there I can solve that now by plugging in what I know. So Sn is 198 is equal to, n is what I'm trying to find, I don't know that. Two times my T1 is 10 plus my n, again I don't know my n, minus 1 times my difference is 3, I do know that. Okay, so I've plugged in what I have. The terms that I don't know are my yellow, I'm going to just highlight them with yellow, sorry, my n's. Okay, so then I can simplify all of that, and I end up with bringing across this 2 is probably the best thing to do first of all. Okay, so I end up with 396 is equal to n on 20 plus 3n minus 3. Okay, and again remembering, so I brought that 2 over, that was the first thing I did. And then I had to multiply this 3 by n and this 3 by negative 1, so that's where those last two terms came from. Okay, just not to leave anybody confused. And then I can expand out my brackets, so 396 is equal to 20n plus 3n squared minus 3n. Okay, and I'm going to end up with a quadratic, so I get 3n squared plus 17n minus 396 is equal to 0. And I can straight away open up my two brackets, get equal to 0, n and 3n, so 3 is a prime number, so that's pretty easy, and 396, you might have to play with this one a little bit, but you get 9 times 44. If you wanted, if you were doing this with a calculator paper as well, you could use your CAS to solve that quadratic, and it's a minus and a plus. So n is equal to 9, or n is equal to negative 44 divided by 3, and we know that our n can never be a negative number, so I can cross that one out. My answer is 9 terms. Okay, so there's 9 terms in that series. And that's it. Okay, next example. So in this example here, the sixth term of an arithmetic sequence is 23, and the sum of the first 10 terms is 210. Find the sum of the first 20 terms. Okay, so again, what can I identify? So I can say that my T6 or my A6, sorry, I'm making a baby T. My T6 is equal to 23. And I know that that's going to be equal to the first term plus 5 differences, because 6 minus 1 is 5. And I know that my sum of the first 10, so S10 is equal to 210. Okay. And I know that that's equal to 10 divided by 2 on the first term times 2, so 2a plus 10 minus 1 times the difference. Okay, so I could rearrange that and say that S10 is equal to 210, which is equal to 5 on 2a plus 9d. So 210 is equal to 10a plus 45d. So I can rewrite that equation, the sum of 10 numbers, as 210 is equal to 10a plus 45d. Okay, and what am I trying to find? I'm trying to find the sum of the first 20 numbers. Okay, so all of that information I can identify from this question, and now I actually just need to work it out. So my solving steps at this point, I'm going to, straight away I should recognize that I've got two variables. So this is my first equation here, so I'm going to call that 1. A and D are my variables, and this is my second equation here. A and D are my variables. So again, I'm going to solve using simultaneous equations. So let's try substitution this time. We did elimination previously. So from this equation 1, I can rewrite that as A is equal to 23 minus 5d. And then I can substitute that one into the second equation. Okay, so take my second equation now and replace A with 23 minus 5d. So I've got 210 is equal to 10 times my 23 minus my 5d plus my 45d. So now I've got all that in terms of d, and I end up with 5d is equal to 20. So d is equal to 4. Okay, and from that I can use my first equation again, which says that A is equal to 23 minus 5 times d, which is now 4. So A is equal to 3. Okay, and so now I know my D and my A, and I'm still trying to find, remember that I'm trying to find my S20. So if I go back over here, I'll raise that a little bit. And now I can plug all that information back in over here. Okay, so S20 is going to be 20 over 2, because it's n over 2 for my formula. Bracket 2 times the first term, which is 3, plus 20 minus 1, which is 19, times the d, which is 4, is equal to, and work it out from there. And I end up with 820. So the sum of the first 20 numbers is 820. And that's it. Done. Okay, so that was looking at the arithmetic sequences and then also going on to the series. Okay, thanks.